Hello everyone, welcome back. So today we'll learn about absolute value inequalities. So first, review our understanding of the meaning of absolute value, and then be able to solve absolute value inequalities, explain what they are, and show how to actually solve them then. So remember that absolute value of a number is the distance from zero. So let's look at a quick example. All right. So remember, absolute value is written as two parallel lines like this. Let's think about the absolute value of number 5. Okay. So what the absolute value says, of course, here's 5, and its distance from zero is 5 units. Okay. But also let's think about -5. Its distance from zero is the same as also 5 units. So the absolute value of 5 is the same as the absolute value of -5, which is just 5. So for a number, it's just the absolute value of any number is just how far it is from zero. It can either be positive or zero, but can't be negative. So this is a distance. All right. So now let's kind of explain the idea of absolute value inequality. And essentially, there are two types of inequalities. When the absolute value is greater than a number, absolute value is less than a number. So we'll look at each. All right. So first, let's take a look at a couple examples to kind of explain the idea. So first, let's just look at this. The absolute value of x is less than 5. Okay. So kind of similar to what we did right above. Let's draw a number line. And remember what this says. This tells us, remember, absolute value is a distance. So what this says, and also why this is called an absolute value inequality, is because the variable looking for is inside the absolute value. And of course, it also is an inequality. What this says literally is that x is less than than 5 units from zero. So it says that x is less than 5 units from zero. Okay, that's literally what that says. So think about what values of x to make that a true statement. Let's think about 5. Now, in this case, 5 is not included since we're using less than. If we had less than or equal to, it would be. So let's just use an open circle. Now, what numbers are less than 5 units from zero? Clearly, anything between 5 and 0 would be true. Okay. And then also think about -5 as well. -5 itself, of course, anything between -5 and 0 would also be included. Okay, of course, not including -5 itself, since it's just less than. Anything between -5 and 0 would also be included. What happens then is that the values that make this true are between -5 and 5, so we can write that as our solutions. We can write them in a couple ways. One thing is just the inequality itself. So x is between -5 and 5. And we can also write as an interval. We can write this as -5 to 5. And once again, since we chose less than, use parentheses. If we chose less than or equal to, then we'd have closing circles, and then these would be square brackets. Okay, that's the meaning. So what this is, when you have less than or less than equal to a number, is look over here on the left, kind of our procedure for doing this. First off, get the absolute value part by itself. These are examples where we need to do that. It says it looks like this, either one of these. Absolute value of x is less than a number or less than equal to a number. We set up this three-part inequality like this and solve it. Now, what if instead we used a greater than or equal to? Let's take a look at that. And I think I can squeeze that in right here. So if we had x, absolute value of x is greater than 5. This would say that the distance, or x, is more than 5 units from 0. X is greater than My handwriting is a little tough tonight. So x is greater than 5 units from 0. Okay, let's think about where that's true on our number line. Here's 0. Now, in a similar way, like here's 5. This particular case, 5 is not included since we use greater than. We use greater than or equal to, it would be. Okay, so 5 isn't true. But any number to the right of 5, 5.1, 6, 100, those are all have a distance greater than 5 from 0. So everything over here, everything to the right of 5. Okay, as you expect, something may involve -5 as well. So think about distance from 0. Okay, of course, -5 is also not included, but anything to the left of -5, so -5.1, -6, -100, anything like that, would also make this a true statement. So anything to the left of -5. So here, our solution, we can write a couple ways. It's two inequalities. What this becomes is that x is greater than 5, and then you can also say just or x is less than -5. That's an equality form. That's what these two intervals would say. X is greater than 5, or x is less than -5. And if we'd use less, greater than, or equal to, we would put the correct signs there. And then as an interval, write this as -infinity. This first one, -infinity to -5. Parentheses here, of course, for infinity always, -infinity. Here, parentheses because we used less than. And then here, this interval goes from 5 to 0, 5 to infinity, parentheses in both, and also the union symbol. Okay, so when we have something greater than or greater than equal to, that's our next bullet point here. If it looks like this, the absolute value of a number, the absolute value of x is greater than a number or greater than or equal to a number, set up two inequalities of x is greater than this number on the right or less than the negative value of the number on the right. And that's how we solve these. So let's take a look at some examples. So our direction is just be to solve. So let's look at our first example, look at a few basic ones, kind of get the feel for it. Okay, so first, let's say we have this. The absolute value of x plus 5 is less than 9. This time we're less than or equal to 9. Okay, so once it says, what this says, whatever x plus 5 is, it has a distance from 0 is less than or equal to 9. Okay, what that says is that x plus 5 is between -9 and +9. So this follows this first one here. So we set up a three-part inequality like this, because whatever x plus 5 is, it's less than, its distance from 0 is it's less than 9 for this to be true, or essentially it's greater than or equal to -9. So we said this three-part inequality. And we just solve that. So subtract 5 from all three parts. So we have x in the middle. And then subtract 5 from -9, that's -14. Subtract 5 from 9, that's +4. Okay. Then if you look at that on the number line, I'm going to draw a number line, then find our interval. Here's 0. Here's 4. Here's -14. In this case, because we use less than or equal to, both our endpoints are included. So use closed circles. Basically saying those two values and everything in between them. So then our solution as an interval, or this is also our solution, but as an interval, it's going to be -14 to 4. In this case, since we're at less than or equal to, we have square brackets. Okay, now, what if we just reversed this inequality sign? Let's take a look at our next one. The absolute value of x plus 5 is greater than or equal to 9. Okay, so kind of in the reverse way, this says whatever x plus 5 is, its distance from 0 is greater than 9. Okay, so that means that x plus 5 is greater than or equal to 9. It's essentially saying that's to the right of 9, or x plus 5 is less than or equal to -9. It's to the left of -9. Okay, that's just following this pattern here. Absolute value of x the absolute value of x is greater than or equal to a. The set two inequalities is x is greater than, in this case, greater than or equal to a, or x is less than or equal to negative a. Okay. So it's greater than or equal to, we set up two inequalities like that. And then just solve each one. Subtract 5 from both sides. So over here we have x is greater than or equal to 4. And over here, subtract 5 from both sides. X is less than or equal to negative 14. If we draw a number line, and we'll see, since as you expect, we just reverse the inequality sign as we related to this interval we drew up here. So here's 0, here's 4, here's negative 14. So in this case, it's the or equal to, so both endpoints are included. And then what this says is that x has to be greater than or equal to negative, greater than or equal to 4, so to the right of 4, or less than or equal to negative 14, then to the left of negative 14. So our solution as an interval, once again, these are also solutions, but as an interval, this interval is negative infinity to negative 14. Of course, always parentheses with negative infinity, and then the square brackets, this negative 14 is included. This interval goes from 4 to infinity, always parentheses with infinity, and since 4 is included, square bracket in the middle, the union sign. Okay. All right. Let's take a look at our next example. Let's take a look at a couple that have a little more going on. This time, let's say we have this. So we have the absolute, call this number 3, the absolute value, which I don't need this. The absolute value of x plus 2 plus 3 is greater than or is less than 5. Okay. Now, notice this one's a bit different. We have something here else on this side, on the left side. So we look at the first step, which says get the absolute value part by itself. So when we get this part by itself, so get the absolute value by itself. And to do that, subtract 3 from both sides. So now we have x plus 2 is less than 2. Okay. Now, this is less than. So once again, it follows this pattern here. Less than number, we set up the compound inequality. So that means that the distance of this is less than 2 from 0. So that means it's between, so that means x plus 2 is between negative 2 and positive 2. Okay. We just solve this, so subtract 2 from all three parts. And so that gives us x in the middle. And then over here, subtract 2 from negative 2, we have negative 4. Subtract 2 from 2, we have 0. All right, so then if we draw a number line for that one, here's 0 and here's negative 4. Okay. In this case, neither endpoint's included since we just used less than. And so both open circles here and basically everything in between. Then our solution is just negative 4 to 0 and parentheses since we start out being less than. The endpoints are not included. Okay. Number 4. So number 4, let's say we have this. So 2 times the absolute value, 7 minus x, is greater than 2. Okay. Now, same thing. So get the absolute value part by itself. If we do that, we divide both sides by 2. That gives me then 7, absolute value of 7 minus x is greater than 1. Since we divided by positive, we don't change our sign. Okay. Now, this is greater than, so we follow the second step. So this means that whatever 7 minus x is, it's a distance of greater than 1 from 0. That means that 7 minus x is greater than 1, or 7 minus x is less than negative 1. We just solve each inequality. Okay. So first subtract 7 from both sides. So we have negative x is greater than -6. Now, divide both sides by -1. That's going to reverse our inequality sign, so we have x is less than 6. Over here, similarly, so which just looks like a 1, not a 7. All right, subtract 7 from both sides. We have -x is less than -8. Once again, divide both sides. The writing is a little hard for me tonight for some reason. Divide both sides by -1. That reverses our sign, so if x is greater than 8. All right, once again, let's draw a number line to see our solution if we write this as an interval. Here's 0, here's 6, and here's 8. Okay, in this case, neither one's included since we just use greater than, so open circles. Okay, so x is greater than 8, so to the right of 8. X is less than 6, everything to the left of 6. So our solution as an interval. Of course, remember these inequalities also give us our solution, but our solution as an interval. Also can put or here if you like. This one goes from -infinity up to 6. And parentheses here, in this case, since it's not included, parentheses there. This interval goes from 8 to infinity. Always parentheses with infinity or -infinity. Then since this endpoint is not included, parentheses here. Then finally, well, make sure it looks more like a parenthesis, not a square bracket. And then finally, union symbol in the middle. Okay. Let's quickly take a look at a couple more unusual cases you might run into. Okay, so what number should be number 5? Okay, 5. What if we had this? The absolute value of x plus 2 is greater than 0. Okay, now it's a greater than, okay, in the same way. So we follow the second one. So it means that, right, two inequalities. So it means x plus 2, whatever it is distance is greater than 0 from 0. So x plus 2 is greater than 0. Or follow the same way that x plus 2 is less than -0. Of course, 0 isn't negative, has no sign. So this inequality would simply be x plus 2 is less than 0. And notice these are two different inequalities. They're not the same one. So but solve each one. So subtract 2 from both sides. X is greater than -2. Now over here, subtract 2 from both sides. X is less than -2. So we draw a number line for that. And here's 0. Here's -2. Okay. In this case, -2 is not included. So since it's not included, first when x is greater than -2, everything to the left of everything to the right, rather, of -2. X is less than -2 over here, everything to the left. And actually, it turns out in words, we can simply say the solution are all real numbers except -2. Still, let's write that as an interval. Okay, so first interval is -infinity to -2 with -2 not included. Second one is -2 positive infinity, let's go with -2 not included, and union sign in the middle. So in words, that simply says all real numbers except -2. Okay, and one more unusual one you might see. Not the only unusual ones, but another one. Let's say we have this. So number 6, we have the absolute value of x minus 4 is greater than -2. Okay. Now, understand this one goes back to understanding of absolute value. Now, ordinarily, might think we do two inequalities, but look at this. Remember, absolute value is a distance from 0. Okay, absolute value is a distance from 0. And distance, of course, is never negative. Distance is always positive or 0. It's not negative. Okay. The thing what this says, absolute value of something is greater than a negative number. It turns out, actually, that's always true. Okay. So here, our solution is all real numbers because whatever this is, it's always going to be, its distance from zero is always going to be greater than -2 because distance always has to be either positive or zero. And zero is greater than -2, and any positive number is always greater than -2. Okay. And that's our solution. We can also write as an interval is just negative infinity to infinity, 'cause that's another way with an interval to write all real numbers. So essentially, any number you can plug in is going to make this a true statement. That's why I said this is a bit unusual. Okay. In this case, that's because absolute values always has to be positive or zero. So it's always greater than any negative number. So it could be any negative number you put here, that'd also be true, not just -2. Okay. Let's kind of recap what we've learned. So we reviewed what absolute value meant as the distance from zero, has either positive or zero. We took a look at two different cases where you have what's called absolute value inequalities, where the absolute value, the x or your unknown variable is inside the absolute value. One case where they have the absolute value of x is less than some number. In that case, you set up a continuous inequality like this. Or the other general case is where it's greater than some number. We set up these two inequalities like this, and we follow this pattern here. Of course, also get the absolute value part by itself if you need to. And so that then is how we solve absolute value inequalities. Thank you. Have a good day.